All right, get kicked off. Man. All right, we got a lot of new faces here. So I'm Alex, one of the organizers for the meetup. I also work here at SalesLoft. Welcome, everybody. Thanks for the great turnout on a crappy night. First off, I just want to say thank you to Chick-fil-A for providing the awesome spread over here and to SalesLoft for hosting. So if we can get a round of applause for those guys. Thank you. Just general announcements. Next meetup is going to be at Full Story on the 21st next month. We still need speakers for that. So if anybody has a topic they want to talk about, feel free to run me down or reach out to any of the organizers. You can find me or Dennis Coyle or Brian Akins on Tech 404, and we'll see if we can find something. So generally, we open up the floor to ask if anybody is hiring, if anything relevant to the community. If you want to just stand up and call out if you got any open roles. Cool. Cool. Anybody else?
I work at a local startup, Prometheus. We're hiring. We work in the airline industry for Jauch working. We're all Kubernetes on AWS. We're hiring mid to senior level engineers interested in tackling issues travel industry. So yeah, reach out if you're interested. Awesome. I'll be around.
Cool. Anybody else? All right, cool. SalesLoft's also hiring systems engineers right now. If you're interested, come talk to me or find Scott back there. All right, cool. That does it for our announcements. So our speakers tonight are Caleb and Laura from Chick-fil-A, coming to talk to us about their massive investment in Kubernetes and tell us all the interesting things they found. So I'll turn it over to them.
All right. Hey, guys. So we're Caleb and Laura, and I want to begin by apologizing to you for the title of this presentation. It makes me very uncomfortable, but Caleb got to it before I could, you know, right the ship. So, so sorry. All right. So who we are, we work at Chick-fil-A. We're site reliability engineers at Chick-fil-A. So going after the DevOps model pretty hard, and we basically consult with other teams. We're embedded on a team and then act as a coach to that team for things around deployment, monitoring, reliability, representing those interests as a developer on the team. So that's what we're about. And so we're going to talk about kind of why Kubernetes. It's not just because of all the cool buzzwords. It does solve a real problem for us. So we're talking about how we're using it, our architecture, and then we're going to spend some time talking about the monitoring because that's the part that we're specifically interested in our role as site reliability engineers. And then we're going to have a lot of time for Q&A. And I think you can even interrupt us if you have questions. Yeah, we got lots of time. So if you have a question, throw your hand up in the air and let's talk about it as we get to it. Sound good? Cool. I'm going to hand it over to Caleb to get us started.
How's everybody doing tonight? All right. Who liked the Chick-fil-A fan? Yeah. Thank you. Yeah. Who likes chicken nuggets at Chick-fil-A? Raise your hand. Like, get it up high. Yeah. There we go. Okay. Who likes Chick-fil-A sandwiches or Chick-fil-A biscuits? Keep them high. Keep them high for a minute. Who wants to work for Chick-fil-A? Keep your hand high. Hey, Jason in the back, can you start taking it? No. Now, so the reason that we do this stuff is we're unabashedly hiring lots of engineers. I'm actually looking to replace myself on this project so I can work on some higher level SRE tasks. So if this stuff is like cool and interesting to you, then come and see if you've got what it takes. Some of the other roles we're hiring for are senior lead engineers, looking to lead some of our teams and other similar problems, and also QA. So there you go. I've said that. Now I'll give you guys a presentation. Yeah, there we go. That now releases me from the money that I get to charge to Chick-fil-A. So we very purposefully want this to be informal. There's enough people that it's a small enough group. You can interrupt us while we go through it. There's a lot of kind of confusing things that we did. We're going to try to explain why we did it, but we don't really want to just be talking heads. Laura and I have lived and breathed this over the last year, so the real power in this talk is going to be in the questions and answers, not in the pre-prepared material. If we get too technical and you aren't really following, you can ask a question. We want you to be able to follow us and kind of stay connected with the journey. If we're not technical enough and you're like, why in the heck did you do that? Then feel free to press us with questions and answers. And we're not afraid to tell you that we don't know, because we don't. So we'll tell you about what we did do. So a quick agenda. We're going to go through our unique challenges. We're going to go through how we're using Kubernetes. Specifically, we're going to talk about how we're using Kubernetes in our restaurants. We're also using Kubernetes to back the APIs behind our Chick-fil-A One app that I'm sure half of you have probably ordered through. It's very, very cool, but we're not going to be talking about those pieces. I'm sorry. There's a guy here. Well, I'm not going to point him out. Maybe you can find him in the crowd that knows way more about that topic than I do. Laura's going to touch on how we do monitoring. So we're very biased for both SREs. We have touched more general software problems as well, but we both come from a perspective of reliability, not just feature development. So just keep that in mind. When we give you our opinion, it's an extremely biased opinion, so take it with a grain of salt. And then hopefully we'll have plenty of time with the QA. We try to keep the slides to a minimum so we can get into the interesting stuff. If we only end up being here like 30 minutes and you're not interested in this topic, that's totally fine. You don't ask any questions, it's because we suck as presenters. All right. So why would we put ourselves through putting Kubernetes in 2,200 restaurants? That's pretty much insane, right? I think I've got a meme up here. There we go. Good old Jackie Chan meme. So I'm here to answer that question. We've actually written several blog posts on this. So if I don't answer the question thoroughly enough, we have much better documentation than what I can give you live. But we actually do have a reason for it, I promise. You guys probably know the Atlanta suburban equivalent of this ridiculously long line in New York. My wife and I, who happens to be here, by the way, we actually saw this restaurant in New York. This is in the Wall Street District, maybe a couple months or so after it opened. And it was like 10 minutes before Sunday, which you guys all know what that means. And this thing was like wrapped around the corner. But they still cleared the line. It was amazing. I think they worked 5 minutes past midnight. Don't tell anybody we worked on a Sunday. And they got through it. You guys have felt that same feeling when you're going through the drive-thru, okay? Like, I've got 30 cars in front of me, but I know in the next 5 minutes I'm still going to get my order. It's pretty insane. We do 3 times more than the next competitor in terms of sales per location. I forget the exact figures. I think this number is a year or so outdated, so it's probably higher now. But I think it was like we do $600,000 in sales per month per location, and McDonald's is to like $220,000, and they're the next highest sales per location. So we do an insane amount of volume through the kitchen. Now with that volume, you would think Chick-fil-A just wants to just build a whole bunch more restaurants. The truth of the matter is Chick-fil-A is very, very careful because it's a privately owned company. It doesn't have all this cash it can just burn through. The operators, when they build a restaurant, they aren't the ones putting up $2.5 million per location. Chick-fil-A puts up their own personal cash per location, and we don't carry debt. So that means that we, instead of building a whole bunch of restaurants, we want to really maximize the restaurants we have. Technology has become a big enabler of allowing that kitchen to really churn through product. Not only that, but we're also very customer focused. So not only are we struggling with this cap that we have on what we can get through the kitchen, kitchens that were not designed to do this volume, by the way. But we want to get people out of the kitchen so they can get in front of customers, and so we can tell people my pleasure more often, okay? So in order to do that, They asked, what can we do to solve this problem? Well, we're going to turn to technology. So I'm going to take a quick sidestep here. So who uses AWS? Any AWS users? Okay, we got quite a few. These are some of their data center locations. Any Azure or Azure, however you pronounce it. Okay, some people were forced to use Azure. Okay. Anybody still using Google Cloud? Okay, you guys should probably think about what you're doing for. All right, I'm kidding. So we're an AWS shop personally. I think we're in talks right now. I probably can't tell you that, but we are with Google Cloud. I mean, they're really cool, but like they don't have that many locations. So we decided we were gonna announce Cloudflare. So you guys can buy some data center space from us in the near future. These are all of our restaurants. It'll be Kubernetes enabled. And no, I'm kidding. No, but in all seriousness, this is a map of all of our restaurants. And this is a map where probably by the end of this year, maybe pushing into next year, we will have a Kubernetes cluster on the edge in each restaurant. Now, fortunately, we have a team of about 300 engineers doing this project. I'm kidding. It's me and Laura. No, there's about 5 people total that are launching these clusters. So when you talk about launching and managing Kubernetes at scale, at an extreme scale with very, very, very insanely few people, that's the problem we're solving. Now, back to the bias thing. We're heavily biased. Most of you are probably not dealing with this problem, okay? So I'm gonna give you my very biased opinion about how to solve this problem. You need to take the pieces that actually apply to you and not try to solve this problem the way we did. More than likely, oh, actually, you know what? I'll get to the next point in a moment. Let me talk about the solution we came up with. So these are the tiny little data centers we came up with. So Chick-fil-A being a privately held company, we can't just burn money on projects. We've got to be very strategic in our investments. They told us like, hey, we want to launch microservices at the restaurant. We want to do IoT at the restaurant. We need brains there. Why at the restaurant? Why not just the cloud? Because our restaurants experience network outages all the time. So if you've got a robot that's frying fries automatically, that thing can't be out of commission when your service provider has a blip. I mean, we use Comcast. This is like not, I'm just saying. Yeah. I hear a couple other names in there. I won't name like AT&T or anything, but my point is it's got to be able to function at the edge without any connectivity to the cloud. And when it reconnects, yeah, we're going to get all that data, right? We care about data. But we wanted to function at the restaurant. You guys, we want you to walk in the store, be able to order something. The internet's down, and you don't even know it. Unless you get your laptop out. But it's not Starbucks, people. Move on. So we didn't have a big budget. We couldn't put load balancers and blade centers. I'll show you the rack here. I mean, this is not a data center. I mean, this is an aggressive environment. There's grease everywhere. I mean, there isn't a technologist like within 10 miles of most of these places. So this is a very hostile environment for this sort of project. So we just didn't have the funds, the interest, the money. It wouldn't last putting blade centers, putting load balancers, putting heavy duty network equipment that would stand this sort of project. So we settled on these Intel NUCs. They're $250 a pop. They're quad core processors, 8 gigs of RAM, 128 gigabyte solid state drive. This is our Kubernetes cluster. This is our data center. So when you rent from Cloudflare in the future, you know what you're running on. The way that these guys work, and we're going to get into the architecture a little bit deeper, is they show up, somebody that doesn't understand what they do, plugs them in, gives them power, gives them network. They find each other, they cluster up, they go out to the internet because there's no ports open on our restaurant, so they have to do pull-based everything. And they pull down our services, they pull down our applications, they apply them, and voila, we have a working cluster in a restaurant that can do stuff, whether it's IoT, whether it's microservices, whatever we want to launch that will persist an internet outage now works at the restaurant. So back to what I was saying before I got to that slide. So word of caution. So don't try this at home, kids, please. This is not necessarily going to be what I would recommend you solve your problem with. More than likely, most of the people in this room, not everybody, but most of the people in this room, I'm saying, look, go with GKE, go with EKS, don't roll your own control plane. Don't get to know CNI networking at a granular level. Trust me, it adds no value to your career resume, move on. It is a problem we had to tackle, so we'll talk about it because we're full of ourselves and we're going to tell you what we did. But for most people in this room, use what other people have rolled for you. They put a lot of work into it, and there's a reason for that. This is a very complicated solution. Who in the room has worked through Kelsey Hightower's Kubernetes the hard way? Okay, my condolences. I am so sorry. I actually asked, so Kelsey Hightower came on site and talked to us about this solution, and I actually asked him privately, like, what did you think about, when you wrote that, what sort of response did you get from the community? And he was like, pure hatred. So anyways, it's doing the control plane by hand at the edge on bare metal is not an easy thing. So, all right, I'm gonna move on from this task, but please don't forget that. All right, so these are some of the challenges we hit. I'm gonna start blowing through this because I'm probably using up a lot of time. So the first and foremost, this is a cool solution. It does a lot of cool stuff. At the end of the day, the only thing that actually matters is getting code that works into production. So every decision we made, whether it was considering Docker Swarm, whether it was how we're gonna monitor it, whether it's how we're gonna deploy it, we always brought ourselves back to the question, are we actually helping people get production code out into the wild, or are we just doing what we're doing because it's cool? So keep that first and foremost. If you're working with old tools, guess what? If it helps you get code into production, keep using it, okay? Because that's really the only thing that matters. In this case, Kubernetes happened to help us do it, but don't mistake an ends to a mean, all right? Or a means to an, whatever, you get it. So we needed to make it very simple to install. Doing this at scale with 5 people, obviously we don't have time to take phone calls. It needed to be remotely accessible. Easier said than done when you don't have any open ports open in the restaurant. We needed the ability for the devices to find each other. I'm gonna pretend like we've largely solved that problem, but the truth of the matter is there's still some things going on there, but we'll talk about that. And we also needed them to automatically, after they found each other, elect a leader and create a cluster, and boom, you've got a Kubernetes cluster. We also didn't have load balancers. So if you guys are interested in writing this one down, Metal LB, can't recommend it enough. If you've got 3 devices on a network and you need to essentially make them act as their own load balancer, Metal LB lets them have an election, pick a leader. That person or that device will then get a virtual IP, expose itself. You can map a DNS entry or whatever you want to it. If it dies within less than a second, another device will win the next election and take over that virtual IP, and you can just keep rolling. So voila, no more load balancers. And it has to be self-healing. Got a question? Great question. We started off with Docker Swarm. The biggest appeal to Kubernetes with us, one of the reasons we switched to it, there were a few reasons. One is sidecars. So funny enough, we haven't implemented it, but the beauty of sidecars, Istio, and similar projects is that if you've got a database developer over here, he or she can make a sidecar. And if you've got a developer over here making a microservice, all they do is call localhost port, I don't know, 83, or you can make it up. They don't have to authenticate. They don't have to keep credentials. They don't even have to know what they're dealing with. Literally, the developer that made the database can send a sidecar pod and it can launch together. A better example would be logging. So we're very interested in logging. We can make a logging sidecar. We can tell all the developers, when you finish programming, just log to port 9090 locally. We can send a pod out with their work. We can handle Elasticsearch, cloud, wherever we want to send those logs, we can handle that. Unfortunately, at the time, we did not have a great solution with Docker Swarm. The other thing we found in Docker Swarm too is like IPs would linger, SSL certificates would linger. It was maybe they've improved it. Although if I'm being really honest, I'm not crazy about Docker as a company. That's just me. They tend to like start really well on a project and then they never quite finish. That includes Docker. Don't tell anybody I said that. But yeah, did I answer your question? Okay, I know I kind of droned on. All right. Any other questions like that? Feel free to just raise your hand. All right. So self-healing. So obviously with 5 people and 6,000 devices and 2,000 clusters-ish, we don't have time to troubleshoot stuff. So the beauty of Kubernetes, why we didn't just go old school, forget Docker and all that, let's just push our apps out, is when a node dies, Kubernetes does a beautiful job seeing the workload die, moving it off to another worker, moving off any database elements that still exist, any data elements that still exist using etcd, and resurrecting that workload in under a couple of seconds, you know, sometimes maybe 5 seconds on the high end. And you don't even know it happened. So, I mean, that's the main reason. We don't really want to maintain this stuff. So that's why we chose Kubernetes, and we didn't go with a more traditional solution. All right, so I'm going to give you guys some terms because in the architecture diagram, I'm going to use these terms, and I want you to know what they mean. What's my time right now? Okay. All right, cool. Perfect. I'm going to try to, when I did a dry run of this, I took like forever to go through the architecture diagram, so I'm going to try to avoid that. So write down, I'm going to hit this stuff high level, write it down for the Q&A because we really want to get to that because that's where the fun's at. So HAMS stands for here's another metadata service. It's funny because it's not even a metadata service. We hacked it away from that. It's more like a management service, but it originally meant metadata service. I don't want to talk about it. So when the NUCs, when the next unit of computes check in, they hit the restaurant, they detect that the location that they're at is a restaurant. They then call up to the service HAMS and they say, hey, I'm here. They check in, they get recorded in a DynamoDB. So we now have a log of the NUCs that have checked in, the locations they've checked in. DynamoDB is awesome, by the way. And then HAMS turns around and says, cool, you've got Ubuntu, Bare 1804, networking sucks on 1804. I don't want to talk about that either. But you've got Bionic Beaver, you've got a provisioning script, you're at a restaurant, I've checked all the boxes. You got an installer there that's physically installing it, cool. I'm gonna hand you a bootstrap script. So all the stuff we actually wanna do to that device then occurs after it checks in with our provisioning service. It also allows us to remotely wipe NUCs. So I'm gonna talk about Overlay FS, which is our really cheap way of not having a second NIC on the NUCs themselves. Because we didn't have enough, well, we had enough money because we're cheapskates. And we didn't want to buy devices that have 2 NICs. We couldn't actually put an imaging server in the restaurant to image these devices remotely. So Overlay FS is our hack around in order to get devices to image themselves. It's like a doctor doing surgery on itself. It's a really gruesome example. All right, so other terms I want you guys to know, Fleet, Atlas, and Vessel. So basically these all 3 work in concert. We're gonna open source Vessel about -2 weeks ago. The guy that's laughing right there is the guy that hasn't done it yet. Hey, you wanna raise your hand high, Sean? Okay, could you open source Vessel, please? Thank you. So these work in concert. You guys think that was a joke, by the way. That wasn't a joke at all. Anyways, all right. So Fleet is a UI that we use to, at scale, edit the configuration files, what you guys would know as Kubernetes YAML files, at the restaurants. And once it's done generating those configs, you've probably used Helm to do very similar things. What it does is Fleet through a UI, Fleet and a CLI actually. Fleet pushes those configurations out to Atlas, which all Atlas is this 2000, well, they don't exist yet because we haven't finished this project, but they will be 2,200 GitHub repositories, 1 GitHub repository per restaurant. And once it pushes those Kubernetes config files up, we expect that that restaurant should match the assigned GitHub repo, the Atlas assigned to that restaurant. Vessel is a pod or a container that runs at the restaurant that's constantly checking that GitHub repository and saying, hey, the last hash I applied on this cluster, is it the same hash as what's currently in GitHub? And if it's not, if it's changed, then we do a git pull and we do a kubectl apply. And yes, I call it kubectl. Hot debate in the industry. So again, Fleet's the UI that generates the configs. Atlas is the GitHub repositories, one per restaurant, which is really nice, by the way. If you're ever like, man, what did I install in that restaurant or what's currently there? You can literally jump right into GitHub and you could see that restaurant's current configuration state, which is beautiful. And not only does it apply the configurations, but if you apply any other configurations that shouldn't be there, it'll actually remove that. So it actually says, oh, you manually changed your cluster. Okay, well, I'm going to now drop that config. Very annoying if you're trying to update SSL certificates. Very annoying. So, and then Vessel's what checks Git constantly and pulls down configs and applies them. I just told you what's below it, so I'll skip that. All right. So this is kind of the journey of a NUC. So this is a NUC with Ubuntu and an initialization script. That's it. That's all it's got on it. Shows up at the restaurant, checks into Hams. Hams then sends it a bootstrap script. And that bootstrap script installs Docker, installs Kubernetes, installs SSM. By the way, AWS SSM stands for Simple System Manager. It's an agent that runs locally in Linux. It checks up to AWS. If you've given AWS any recent commands and you're like, hey, I want you to run this on my fleet, all those boxes will pull that command down and execute it locally. It's very cool. If you want to control thousands of machines and thousands of networks at once, SSM is your way to go. Very expensive. We'll probably abandon it next year, but whatever. It's a very cool solution. Have not tackled that yet. No. In our version, I think we've gone from what, 11 to 12, and so far. So, great question. So the way that we upgrade is we wipe all the boxes and send them back to square one, right? So I'm an SRE. I'm really lazy. There's only a few of us, so we just nuke everything. That's how we roll. So if I wanted to upgrade Kubernetes, as he asked, I would update the bootstrap script. I would find an appropriate time because you're talking about a 5-minute outage or so. It's not insignificant, the amount of time. And I can schedule this, although I think right now it's still manual, but I could schedule this in theory. I would tell it, hey, the new bootstrap script is a new version of Kubernetes. I would then send a command out and I would say, everybody wipe yourself. And so all the boxes would erase everything on the box. They would go back to the original state that they shipped in. They would re-download the new bootstrap script. They would install the new version of Kubernetes and they would create a new cluster. So great question. Yeah, that's right. I have had outages on Sunday. That's true. It's been very convenient. Yeah, so that's a great question. I don't know if you want to tackle that. Yeah. So the way we do CVEs is, again, we update the bootstrap script. We would add it in the bootstrap script. We'd say, hey, we know you were a bunch of versions behind. We now want you to be current. We'd add it to the bootstrap script. We wipe the device. I mean, we are serial nukers. We just nuke the stuff. Other questions? That's a great question. So here's the truth. The truth is we're in a handful of restaurants right now. So right now we're manually going through and updating this stuff. We're about 95% of the way through with fully automated scripts. Ultimately, we will probably upgrade one device at a time at night, let it sit maybe even for multiple days, and then upgrade the next devices as long as the CVE or whatever we're changing gives us the breathing room to do that. Because if there is a problem, the beauty of Kubernetes is I can go down to one node. So if I screw the nodes up, as long as I have an old node running, I could just run off of that guy. But so the answer to your question, great question. Sean, which by the way is an insider, that wasn't totally fair. Yeah, we will go one at a time and we'll give time between those so that if we screw something up, we know during the day. Yeah, there probably is. Again, you want to? Do you want to take it? Okay. I don't want to hog all the time here because she's actually more knowledgeable than I am in a lot of areas. So I want to make sure she gets some questions too. Yeah, so I can't answer that question for security reasons. That's a great question though. To answer your question, we're lazy and we use stuff we're familiar with. Yeah, there are much lighter versions we should probably be using. shell scripts. Don't tell anybody. Yeah, they have to be, because we kill them so often. Yeah. Eventually, we'll get a high availability version of Mongo. Right now, it's single node. Okay, we'll get an HA version of Mongo that should be sufficient for preserving data. We'll set up an HA version of NFS across the devices. That should be sufficient for just shoving things in there. Eventually, we'll get to a point where a rolling upgrade means that we can preserve data. Currently, we just get the data out as fast as we can, and we just accept the losses. When you got 5 people, you got to make trade-offs. So, great question. No more questions. Oh, we got one in the back. You say only like it's a problem. No, I'm kidding. Yeah, so you can run masters and nodes on the same device and have 3 of them and then have the master roll. Unfortunately, you can do that with RKE, which we recently abandoned. You can't do it with kubeadmin. I haven't been happy about that. Right now, we essentially have a single master and 3 nodes. If the master happens to die, we quickly rebuild through, guess what, the nuking process. So that's ultimately, to answer your question, I want to have 3 HA masters so that the control plane survives. But even if I have a 2 to 3 minute outage for a rebuild when a master dies, that's sort of an acceptable downtime for us. Actually, to be honest, so I don't want to be alerted longer than it takes to make a cup of coffee. It's my coffee fix is what I call it. If an alert takes longer than a cup of coffee, by the time I'm done making coffee, if the alert's gone away, it's fixed. So my boss is the guy wearing the red shirt in the back. So because he's here, I'm going to say yes. But no, I don't. I'm a coffee snob. So if I wasn't a coffee snob, it'd be great coffee. So virtualizing, you want to elaborate? So you remember the part where I said I was lazy? That sounds like a lot of work to me. That's a great point, though. That's a really great point. And if I was more motivated, I would probably continue that discussion. All right, so we're going to roll through this. I've burned a lot of time. This has been a lot of fun, though. And so hopefully we have a lot of time at the end. All right, so a NUC shows up. It's got 1804. It's got an initialization script. Checks in with hams, hands at the bootstrap script. It continuously checks back in with hams. So it's checking back in constantly, and it's saying, hey, like, no, like, should I reset myself? No, like, really, are you sure? Like, really, are you really sure? Should I reset myself? And hams is like constantly, no. And then when it says yes, then what happens is it runs a overlay FS right here. So you can think, if you haven't worked with overlay FS, you can think of it as Git. So it's like, hey, all these changes to the hard drive, including the operating system, so Linux itself, I want to like just drop all of it. And it actually goes back to its original state when we shipped it, which is really cool. And this has worked for us. So we don't have clusters everywhere, but we do have hardware in 1,800 stores now. And this has actually allowed us to manage at scale, 1,800 times 3, whatever that is, I'm bad at math, a lot of hardware with just a handful of people. So it's been very effective for us. So the bootstrap script shows up. It installs Docker. It installs Kubernetes. It installs SSM. It installs Vessel, which again, that's the pod that is pulling down our configurations from GitHub, which we call Atlas. Then I don't want to talk about IP problems unless you guys want to in the Q&A, but IP problems are a nightmare. The master election occurs, so it picks a master and it uses Metal LB in order to essentially act as a load balancer. So the 3 devices have a fight. Whoever wins gets to be the one to serve up the traffic. Good for him or her. Then Vessel goes out. So now you got a Kubernetes cluster, clean one. You've got Vessel is really the only pod of interest running on it. Vessel goes out to Atlas, pulls down all of our custom applications. And then voila, you have a Kubernetes cluster with all of our custom applications. And this process here is happening continuously. This is our deployment method. So it's not just to start the cluster, it's also to deploy new applications. And that is how a NUC shows up and becomes a fully functioning member of that restaurant with little to no intervention. So like I said, we have about 95% of this done. We'll finish the last pieces of it. There's a couple really brilliant developers that we've overloaded that haven't quite gotten to finishing out yet. Oh, what'd you do, Laura? Thank you. By the way, just for the record, there's a guy that's not here tonight. His name's Alex Crane, and he is the mastermind behind this. So I just had to throw his name out there. I told him I would take all the credit for his work. I just couldn't quite do it. All right. So, Laura.
Cool. So since we care about reliability and this is going to be business critical stuff that affects the making of chicken and waffle potato fries, we thought it would be good to know if it was working for the sake of people's sanity in the restaurants and making money, which is what we enjoy doing the most. So how do we monitor this? So we've got a couple different factors to consider. The first is price. Obviously, we don't have infinite money to spend on something like this. And our architecture breaks a lot of pricing models. So people that are charging based on the agent, number of pods on the cluster, those sorts of things, we're gonna mess that up. Exfiltration, as Caleb said, we don't have any ports open in the restaurant. So we're gonna need something that can talk out. We're gonna have to push our logs and our metrics up somewhere else so that we can see them in the cloud. Third, ease of setup. Again, as Caleb said, there's not that many of us, and we're super lazy. So we want this to be as easy and painless as possible, which we've already done a bad job of that, but you win some, you lose some. And then scale. So again, small engineering team, and we need this thing to work. We don't have time to be answering the phone all day and responding to support calls. So we've got all that in the back of our head, and we're trying to think about what do we use? What do we use? And there's so many options. So first, Prometheus. This is like what comes to mind when you're like, Kubernetes, Prometheus, monitoring metrics, let's go. However, it uses a poll model. So you have your kind of master cluster and it's scraping all those metrics endpoints and pulling in that data. We can't do that at a high level. So we could have a Prometheus cluster in all of our restaurant clusters, that main server polling, but then how do we get our information from those at each location, because we can't pull it out. So that broke it. The other thing is now we have a lot of small clusters to maintain all over the place. We don't want to do that. And we don't know how to do one giant cluster that scrapes all the small clusters. So that's more to manage. And there's a couple of solutions out there. So I think Weaveworks had something that was kind of going that direction. There's another thing called Thanos, but neither of those was mature enough for us to want to dive in after it. So we're like, what else do we got? DataDog. So DataDog was our first choice. Caleb has context with DataDog, so it would have been easy to set up. They've got great support. A lot of their stuff works out of the box, so that's awesome. But we broke their licensing model because they do limit the number of pods per cluster. They charge you based on the agent. And like, we're looking at 2,000 restaurants with who knows how many pods on each cluster, like that much money. The other thing is since we're rolling our own hardware, we have to take into account resource utilization. And I think that they've made progress on this since we were first looking at it, but their agent was pretty resource heavy because it was doing a lot of processing locally. And so we wanted to preserve that for restaurant focused applications and not monitoring. So what else? We've got AWS Elasticsearch Service. So this is their AWS's offering, which is like open source minus. So it's great for a POC. Like you can just stand it up really quick, push a button, and you've got an endpoint that you can write to. So that was really good to get us started. But then there was too many limits on what it offered. Namely, we wanted a service called Watcher that Elasticsearch offers, which does alerting off of queries that you write. And we also wanted help with some of that cluster management. So like index rotation, different things like that. You'd have to roll all that yourself if you're using AWS Elasticsearch. So that pushed us to the Elastic Cloud, which had all of the features and was affordable because they charge you just based on that central cluster and the size of that cluster. So we have total control over how much we're storing in that cluster rather than agents and all that stuff. And then we also have great support. So we've had some really helpful discussions with their engineers around architecture and pricing and different things like that. So you can probably guess who the winner is. I set it up really well. Elastic Cloud. So it worked for us in these 4 categories. So price I already alluded to, charged on that central cluster, not based on all the many different agents that might be writing to it. It's a pay-as-you-go, so we felt comfortable trying it out as we're kind of slowly learning how this is going to work and how much data we're going to need to exfiltrate. And based on that central cluster size, exfiltration, all these agents are writing out to the central Elasticsearch cluster. It's not a poll model, so that worked for us with our network limitations. And it's also mature, so lots of people are using this and you can trust it. Ease of setup, all those agents out of the box. You just set up that pod in your cluster and you're going. And then scale. Again, we're pretty young, but so far it seems like it's working. We'll come back and tell you more in the future if you'll have us. But yeah, so far so good. So then agents. So we've got our central kind of solution figured out, but how do we get the data there? So there's lots, not as many options, but still a fair amount of variety. So FluentD is a log agent. I think, did they also do metrics? No, just logs? Just logs. So we started with FluentD, and that was fine. And then we realized that FluentBit existed and uses even fewer resources because it's just straight C. So check that. FileBeat is Elastic's, like, the code is open source, but it's proprietary because you need a license to use it. Their log exporter, and we really liked that a lot. It's very easy to use, very easy to set up, and had some really great benefits from a Kibana perspective. And there was some reason that we decided not to go to it that I'll get into in a minute. And then MetricBeat, which is the metric exporter that Elastic has put out. So ultimately, we landed on FluentBit for our logs, namely because of throttling. So as Caleb said, networks going up and down all the time in our restaurants. Even in our restaurants that have fiber, the network connection can be pretty slim and weak. So if we're not careful about controlling how much we're writing out, we could eat up all the bandwidth and like basically take down the restaurant, which we did a couple times. So lesson learned. But FluentBit had much better throttling controls available than a FileBeat. So, and then it was not FluentD, it was smaller. So we like that about it too. And then metrics, we use MetricBeat. So low resource utilization on the box, which was awesome compared to the DataDog agent. And yeah, so some other benefits that we got out of it. So great visibility with Kibana. So we can give all of the dev teams that are writing apps for our platform access to Kibana, and then they can go and get whatever logs they need from their applications without us being a bottleneck for that project. So we found that to be hugely valuable, especially because they're as much in the development stage as we are and need access to that information in a real context in the restaurant. Alerting with Watcher. So this is great. It's not as a great experience as like alerting with Datadog, which just has a very mature and refined process, but it's been able to do what we need it to do from writing queries and ranges and different stuff like that. And then we send those notifications to Ops Genie. And then automatic Kibana dashboard setup with MetricBeat agents. So the nice thing about using Elastic agents is that you can say, all right, when you get to the Elasticsearch cluster and you find Kibana, I need you to set up these 4 dashboards and like just tell me about yourself. So instead of me having to go in and manually make all these dashboards for 2,000 restaurants, they just show up. It's awesome. And then we look like geniuses because we've got amazing, beautiful dashboards for people to look at. Yeah, slaved all day, all night. Yeah. So that's kind of the basics of our monitoring solution. So obviously there's way more under the surface there that we can get into if you guys have questions, but that's the overview of some of the decisions that we made. So through this overall process, we've learned some good lessons. The first is use what other people have already built. Like, don't try to build it yourself if you don't have to. We talk about this all, we actually argue about which one of us is lazier. It's not true. It's not true. So and Jason tells us this too, like laziness is a good quality in a developer. Don't go over engineer things. So don't reinvent the wheel. MVP, obviously test it before you commit to it. Like take your time and build a good test and really understand what you're working with before you throw everything after it. This is where using AWS Elasticsearch Service was a great way for us to get our feet wet with Elastic and see if it did what we actually needed it to do before we committed to something like the Elastic Cloud. Aggregated and searchable logging, this is so great if you're trying to find issues, like operator calls and they're like, hey, my network is down and we think it's your fault. Like, how are we supposed to figure that out? Because there's so many other things going on in a restaurant. So using aggregated and searchable logging is going to help us figure out what that problem is and then combine that with the metrics that we get, and it's just like a huge value add. And it helps the dev teams on our platform because they can find exactly what they're looking for, because since we're so young, they usually just come to us when their apps don't work. And sometimes it's our fault, but sometimes it's not our fault. It's usually our fault, but this way we can at least help them in a timely fashion. And then deep health checks matter as much as unit testing. So again, like health of the pods, like rely on your health checks, your liveness probes. Let Kubernetes do a lot of that heavy lifting for you as far as is the app up or down. Don't worry about all this other extra stuff to figure out. But just super important to know, like, just because the pod is up doesn't mean that it's like doing what you think it's doing. So we are learning that lesson. And Helm wasn't a good fit for us. Caleb can talk more about that if you guys have questions about why Helm wasn't working for us. And yeah, so those are some of the major lessons we learned. You can find us on the CFA Tech blog, which is on Medium. So we've got more information about this product there, other things about the project. But yeah.
Yeah, so are you referring to like the published Kubernetes audit? Like, I think do they call it Sentinel? I can't remember the name of it. But it's a pod and you run it against your Kubernetes cluster and it literally gives you an output of what's wrong with it. Yeah, no, we haven't gotten into that. Yeah, no, we're not advanced yet for that. Sorry. Yeah. Yeah, so when we built this project out, we also got assigned a dedicated security resource that followed us along the project lifecycle. Now, one area that we kind of cheat in is that this is all very walled off. A lot of the considerations for Kubernetes, like I guess 6 months or so ago, the Kubernetes security flaw that allowed you to escalate privileges in the pod and all that jazz. We looked at our restaurants and we're like, we don't have any open ports. Nice. So we still upgraded it. You know, we did our due diligence, but no, actually we're not, believe it or not. We actually keep PII data off of our clusters, which is really nice. So it's actually not included in the PCI audit.
Yeah, in the back. Yeah, so we haven't seen any issues around that yet, I don't think.
They're fanless.
Yeah, and they're fanless.
They're not technically fanless. They're like really low power fans. They don't actually suck a lot of air into the units. We'll probably ultimately use fanless. Oh, sorry. We'll probably ultimately use fanless NUCs, but it's like very low powered. So a lot of that hostility in the air is not getting pulled into the device. We do have some NUCs with another team that are out in the open area that are directly exposed to that stuff. They might die prematurely. We don't know yet. We haven't been in the project long enough to know what the life cycle is. It's a great question.
and they're not that expensive. So theoretically, if it breaks, you just plug a new one in and it joins the cluster and you're good to go. Yeah, Alex.
Yeah. How much time you got? Yeah, so the question is, why doesn't Helm work for us? So all of you that love Helm, screw you. No, I'm kidding. No, so Helm has a couple of features, and they might have sorted it out. I haven't touched it for 6 months, so if you guys raise your hand and like, Caleb, you're an idiot, it's fixed, please hold me accountable. But 6 months ago, okay. So Helm, first of all, it's got Tiller installed. So all of a sudden you've got an additional pod, which granted we run Vessel, but at least we know what Vessel's doing. We don't even know what Tiller's doing. I regularly had Tiller get out of sync on just a handful of restaurants, much less thousands, where it would stamp over an installation that was there randomly and unexpectedly. It wouldn't pull in something. It would get into a bad state and get stuck, and they didn't have very good health checks to recycle Tiller. I had a lot of trouble with Tiller. The other thing is if I'm being really honest, I'm not this guy in the room, and I had a lot of trouble reading Helm template files. Like, I don't know if anybody's with me, but it's like 3 layers deep, and I'm just not that smart. Somebody raised their hand. I think it's because he agrees with me. Anyways, no, maybe he doesn't. You want to add? Oh, there we go. He did agree with me. Look at that. I was trying to put that on him, and it actually worked out. So we couldn't really reason with Helm that easily. Here's the other thing, and this is really the key, okay, is that we're having other teams launch onto our platform that barely know Kubernetes. To expect them to go into the bowels of Helm and learn how it works. It's one thing to be like, here's a YAML file with a bunch of confusing stuff on it, but we'll tell you what it is. It's another thing to be like, here's Helm, good luck. So yeah, anyways, I'm a big fan of Helm. If I was running in the cloud, I had a even close to normal sort of installation going on, I would be all over Helm. I would probably use KSonnet if I wanted to go real crazy with it. But ultimately for our specific application, and again, you got to hear me out. I'm very opinionated. Let it go in one ear and out the other if it doesn't apply to your environment. But for me, in this sort of setup where I'm servicing large teams and doing things at scale, Helm just was it was just DOA, which really sucks because initially I loved it. And abandoning Helm is very painful for me because I can go out to any project, find a Helm install in about 5 seconds. Here's what I do. I find the Helm install, I tell it to spit it out to a file so I get the fixed YAML file, and then I steal that. That's how I use Helm. Don't tell anybody.
We won't. Yeah. Yeah, so we're really interested in resource utilization at this point, just because we're still learning about how these machines behave. So we've got network, we've got CPU, we've got memory that we're watching. And then we also are interested in like number of pods, what pods are in a good state, what pods are in a bad state, different things like that that kind of give us a high level, like, are we good, are we not good, are we trending towards somewhere dangerous? So I think we've used it heavily on the days that we take down restaurant networks, because it will show us. And then, you know, we're getting better. So now we write alerts. So if the network utilization is like crazy, let me know. Yeah, what is that it?
To Laura's earlier point about using Kubernetes the way it was designed, if you write a thorough health check, then you can just rely on the pod state and not have to worry about all this other crazy stuff that we all want to over-engineer and get to know the state of our application. If you write a good health check and your microservice goes down, Kubernetes knows about it. It's going to try to kill it and move it to another pod or another node. But also you can monitor off a pod state now. Yay. So that's another reason that we're saying this, okay, because we did that. We were like, I don't need to read the whole Kubernetes manual. I'm pretty smart. And then we would go and engineer a solution and be a terrible solution. And then we would go back to the manual and be like, wow, we're idiots. And then we would use it the way it was intended with like 2 lines of code and be done. So don't do that. do it the right way.
Yeah, so like a concrete example of that is we have Vessel, right, which is running on the restaurants, and it's just essentially doing like a git pull every so often to apply that configuration. So there were days where like, Vessel's running, it says it's healthy, it's fine, and it had gotten itself into some sort of bad state, and we had no idea, and our internal customers were like, why are none of my updates going to the restaurant? We're like, everything looks fine, just kidding. We're not paying attention to what it's doing, but yeah. Or,
Identifying the device by MAC address kind of sounds that all the rules have to come to Euro simplified to exist. And they go out, find their own local replacement, and your all the employee will pick it up and register.
great question. I don't think we can answer that for security reasons.
Yeah, if you happen to get in the back of our restaurant
Right.
and start poking around a device, you at least have to choose between cereal and that.
Yeah. Yeah. Back there. It's like, yeah, it was ridiculous. I went to their website, like copied the URL to pull down the template file. And like, you can, like, you just put in, you know, here's where my cluster is, whatever auth information, and it goes. Yeah, so there is it is a little bit gnarly just figuring out some of the like initial configuration. But yeah, if you, yeah, we like tried a lot of different things and then it eventually worked. I don't know if that's encouraging to you. Yeah. I mean, they have pretty decent documentation. Sometimes it's just difficult to figure out what exact piece of it applies to you. So if you just sit down and read it through, I think you'll probably get a good perspective on. Yeah. And I want to systematically do this, but you guys keep raising your hands all over the room. All right. Yeah.
You seem like you're really resource limited. And so have you considered running some more things as daemon sets instead of as sidecars? Say like using Mr. D instead of Istio or something like that that points maps as daemon sets where you run less pods to save on some resource usage?
I don't think we're actually using sidecars right now anywhere.
We plan on getting there. That's one of the next parts of our project.
Yeah.
That's a great point. We do run some daemon sets.
Yeah, we do. I mean, just your basics, but yeah, that's a good point.
Yeah. Solid.
You can pick the question.
No, I'm just
All right, you. I don't know that we've thought that far out yet. I mean, right now we're at like half a nook capacity. Like we've got space.
A single NUC runs at about 30% by itself, the whole cluster. So if it fights all the way down to one device, 30%. And that's a Celeron processor, which means basically running NUC. So we haven't hit that wall yet. More than likely, the recommendation that I'm going to make to the business, and the business ultimately decides, is going to be, I'm almost done.
But these people.
Oh, but them? Oh.
Whoever's watching.
Ultimately, I'm probably going to recommend that we go with like i3s or i5s in the NUCs as opposed to Celeron because we don't want to burn ports and stuff in the restaurant. So yeah, great question.
Yeah.
Did you find that using such a small box placed constraints on your developers as far as how big their applications could be? Did they have to adjust accordingly prior to whatever they were doing before? Or was it pretty much you just let your developers run loose and then kind of figure it out?
Yeah, so far all the apps that they're writing are not existing anywhere else. So this is all new stuff for the Smart Restaurant Internet of Things initiative. So there's no like, you know, what we did do and what we do now. It's just this is what we work on. And I think the only constraint that we've kind of had to consider giving them thus far is network. It, you know, like in some cases they want to exfiltrate some of their own stuff and we just like, hey, be careful. Just keep an eye on it.
And to add to that, almost everything we put on the NUCs are written in Golang. And I don't know if you guys, raise your hand if you've written anything in Golang. My condolences to you too. Yeah, if you say so. I'm not a fan of C. I'm a Python. Like, okay, well, we can agree on 50% of that. But so here's the thing about Golang though, is that if you compare to something like Java that's compiled, it's like the memory footprint is insanely small. Garbage collection is incredibly efficient. Multi-threading is very easy, which I don't think we've had to do yet, but if we did do it, multi-threading in Golang is extremely easy. So by using that as a predominant language, which most of the developers at Chick-fil-A don't use, but we'll get them on board at some point, I'm sure, including myself, which I'm not a fan of Golang. That's beside the point. I can still respect it from a distance. It's made launching applications very easy. I don't know if that helps.
Yeah. Yeah. Yeah, so we have a couple of labs. So they are active on those labs. We're active in those labs. We do our upgrades and then see how it behaves with their stuff. But again, it's a pretty young project, and it's a lot of, is what we're building actually useful? So code in production is what is valuable. So while we do want to test it and be, confident that it works the way we expect, we also don't want to hold on to it for so long. So, yeah. Yeah. Probably have some
Well, probably the most baffling thing, is this thing on? There we go. Was when I got a call from an operator, which like never happens, by the way. Like I don't get direct calls from people that own restaurants. And he's like, "Are you Caleb?" I was like, "Yes, I am." I can't sell anything to my customers right now. My restaurant's down and support has no idea why. They said something about it being a pilot restaurant for this new SmartBot project. They're like, what is going on? And so what had happened is his these devices had gone down for 2 hours, and when they came back up, they decided to ship all their logs at the same time for that 2-hour window over the pipe. And the restaurant, this is the best part. So if a restaurant loses connectivity, the credit card consoles go into offline mode. So if you've got like a credit card you stole, find a Chick-fil-A that doesn't have internet, and it'll automatically accept your. I'm kidding. I'm kidding. Anyways, so anyways, it couldn't even hit that state because it still had an open connection with the cloud, but it couldn't actually move anything across the pipe. So I hadn't closed the connection yet. So it was like, I'm not dead. Don't go into offline mode. I'm not dead yet, but I'm not going to do anything. So it was like in this zombie state. So I didn't know that, of course, and I didn't have all this cool stuff yet. So I'm like logging into restaurants, trying to figure out what's going on. And then I get another call from another operator, and it's like, okay, this is a problem. So we found out that logs can kill things too. Anyways, yeah, I don't know. Yeah, that was a pretty weird one.
Yeah, let's go to the back.
Did he say standards?
So it's a discussion that's going on right now. Just as we learn more about the environment, again, we're encouraging people to write in Golang. Like don't go crazy. But we haven't run into the place yet where we're like, all right, everyone's get under control. Yeah.
It's pure chaos. No. I'm kidding. Like 90% kidding.
Yeah. Yeah. So I would say a lot of the patterns that we've learned are going to be tied more to our specific experience of Kubernetes with the problems that we're trying to solve. So it is sensitivities around like, this tool isn't going to work for us because it can't exfiltrate, things like that. So that's like where we just hit those patterns kind of up front. But like templates, I mean, yes, like we're all sharing knowledge, right? Work together on projects. This is a pattern across like the development world. And as we said before, like it's so easy to work way too hard on solutions because it's cool or because you're lost and confused and don't know how to get out of the hole that you've dug yourself into. Like, so, like, you know, I kind of get to a place in projects where I'm like, I think I'm like, I shouldn't have to, like, I don't know if it's like entitled, like I shouldn't have to work this hard for a solution. So like there's probably another way, like somebody else has probably been here before. So that's like, just as I grow in my career is a pattern, certainly with Kubernetes, is like, someone has probably hit this before me and figured out an easier way to do it. So I try to stop and ask myself that periodically, like step back, what am I actually trying to achieve? And is this the best path to get there? But what have you noticed?
So we architect things that don't exist yet, and then we put them in a filing cabinet, and then we check them in 6 months, and sure enough, AWS has released a solution and we didn't actually build it, so we have nothing to replace now. Okay. I don't know if you guys have been there. Cannot tell you how many times I've written glue code and I came back to AWS's blog and I'm like, shoot, you just did that. Like, anyways. So yeah, if you really want to build something that nobody's seen before, don't. Just wait for AWS's blog.
Like, Caleb, why aren't we using Greengrass or whatever their IoT solution is? Great question. We should be. Yeah. You guys lazy. Just sit on it for 6 months. That's awesome. All right. What do you got? You know this much better than I do.
I don't want to talk about it. No, we're using CNI that I think we recently changed, and I can't remember what we changed to, but we're using the version that ships with kubeadmin native. I can't remember the name of it. It is Flannel. It's exactly what it is. We've had a lot of issues with networking on Bare Metal, a whole lot of issues, particularly around, I'll talk about networking for just a moment. So you ship these NUCs out, they grab their static IPs. I'll just make this number up. This isn't a real range for security reasons, but let's just say they start at 1, right? So you've got 192.168.1.1.12.1.3. And then a week later, they decide they're going to do their DHCP rotation, and they go to 4, 5, and 6. And you're like, cool, right? It's Kubernetes. It's supposed to be really smart. You'd be dead wrong. So not only does the control plane kill all the certificates because it ties the certificates to IP addresses, you can do a whole bunch of like host stuff to like tie the certificate that Kubernetes generates to a non-IP. Fine. If you figure that out, let me know. But then once you get that done, then you're like, cool, I'm good to go. And all of a sudden you have random network errors get thrown in the logs on the pods. I'm like, what is going on? And what it is even on a restart, some of the local kubeadmin pods running the kubeadmin namespace held on to the original DHCP IP assigned to that device. You're not dealing with this in the cloud, right? Because in the cloud, they don't tell you this, but you basically get a static IP once you get a node. If you get another IP on that node, it's because you killed the node. We don't have that luxury with Bare Metal. So we've hacked that to heck and back. The DHCP server signs an IP. We have a service in the cloud that monitors what NUCs are assigned to what IPs, and we basically force them back into the DHCP configuration that they're with. I'm not proud of it, but it works. It's one of the roughest edges. Networking is one of the roughest edges, in my opinion, that we've had to sand off in the Bare Metal Edge NUC Kubernetes solution. So I'm going to go curl up in a ball and cry now.
There were a lot of days we were like, there's nobody that really understands this. Like, right? Like nobody. No, you do. No. We need you. Yeah. But yeah, what's up?
So, I mean, you seem to like nuking enough. Why not just during the DHCP rotation to nuke everything and redeploy? Wouldn't it be alive?
Because the DHCP rotation can happen in the middle of the day.
Yeah.
So I can at least control the nuke on Sunday, right? So I got the whole day. But
Yeah. We can.
officially, no.
Not? Yeah, we just don't sell chicken on Sundays.
Close your ears. Yeah, no, we actually, we do if we have to. I would say, I've been there a year now. I've probably worked maybe 3 Sundays, not full days, just like. a
Log
few hours
on,
here and
check
there.
it out.
So we're highly encouraged to rest, and honestly, come work for us.
Yeah, like if you work on Sundays, you should probably come in late on Monday.
Very reasonable. I get a lot of work-life balance.
What else? We've exhausted them.
Yes.
Oh, yes. It kind of like ruins it because none of us can take anybody seriously when they say it. Like, my pleasure. Like, can't take it seriously. Like even in my personal life, like if it's like something that I genuinely enjoy doing, I sort of accidentally say my pleasure. Everyone's like, you're just saying that. But yeah. All right. Well, thank you so much, guys. If you have more questions or want to keep talking about that stuff, we're both on LinkedIn. Look us up. Love to
Thanks,
keep talking
everyone,
about
for
this.
your time. And it's our pleasure to serve you.
All right, thanks for coming out, everybody. Again, reminder, next month on the 21st at Full Story, and we are still looking for speakers. So reach out. Thanks for coming.